Our problem asks us to find the percent of the total area under a standard normal curve in part A to the left of 0.79. Okay, so let's take a look at a standard normal curve. Looks something like this. Now remember, the mean is the highest point on the curve, and standard normal means the mean is 0. The z value we're given is 0.79, which is positive, and positive numbers always go to the right of the mean. So we're being asked to find the total area to the left of 0.79, and that is going to be this value right here. Now, that percentage happens to also give us the probability that the standard normal random variable z is less than 0.79. To the left of means less than. So, the way we're going to find this probability is from a table. And the table is 2 pages. The first page of the table is going to tell us the probabilities associated with negative values of z. Now, if you look at the table, you'll see the left column is the z column, and all those values are negative. In this problem, our z, you'll recall, was 0.79, which is a positive number, so we get our positive z's from the second page of the table. Now, there is no, if you look down the z column, the leftmost column, it looks like it skips over 0.79 because it goes from 0.7 to 0.8. However, since the first decimal place is 0.7, we're going to use the 0.7 row, and then we're going to move to the right in that row until we're under the 0.09, which is the very last column. So you get your first digit from the left column, you get your second digit from the top row. And where the column for 0.7, the row for 0.7 and the column for 0.09 meet is the answer we're looking for, which is 0.7852. Now, 0.7852 is the probability that z is less than 0.79. However, this problem, it asked find the percent, so you convert the probability to a percent by moving the decimal point 2 places to the right and putting a percent sign. So, can you always just look your answer up in the table like that? Not quite. The table always gives you the area to the left of the number you look up, and they remind you of that by this picture at the top of the table. Notice it shows a z value, and then it's showing you the area darker to the left of it. So anytime you're asked for an area left of a z value, yes, you can just look it up in the table. Part B of the problem asks us for the area between the mean and 0.79. Okay, the area between the mean and 0.79. Well, the mean is 0, so it's asking us here for the area between 0 and 0.79. It's asking us for that area right there. Now, we know from part A that the area from 0.79 all the way to the left is 0.7852. And we also know from our previous movie that this area to the left of 0 is exactly half of the area under the curve, or 0.5. So if the green area is 0.7852 and the blue area is 0.5, what do we do to get the red area that we are being asked to find? Exactly, we subtract. So it's going to be the big number minus the small number, which gives us 0.2852, but again, that would be the probability. The directions here ask us for a percent, so we're going to convert our answer to a percent and answer with 28 0.52%. Now, part C is asking us for the probability between the mean and negative 1.03. All right, the mean is 0. Negative numbers are to the left of the mean. So in this problem, we are being asked for this area right here between 0 and negative 1.03. Now, we know that the area all the way to the left of 0 is always 0.5. We're now going to look up negative 1.03 in our table. Negative numbers will be on the first page of the table. So to find negative 1.03, you go to the negative 1.0 row, and then you move to the right until you're under the 0.03 column, and we see the probability there is 0.1515, and as the top shows us, that's the area to the left of the number we look up. So this area to the left here is 0.1515. So we're being asked for the red area, the area between negative 1.03 and 0. Notice that the 0 all the way to the left is 0.5. Negative 1.03 to the left is 0.1515. If we know that green value and the blue value and we want to find the red value, what do? We subtract the bigger one minus the smaller one, which gives us 0.3485. So if it asked for a probability, you would answer 0.3485. Since it asked us for a percent, we're going to answer with 34.85%. That is the answer to part C. Now, continuing here, we're going to go on to part D. In part D, it's asking us to find the area to the right of 1.3. 1.3 being a positive number is to the right of 0, so we're trying to find that area right there. Now, let's look up 1.3 in our table. It's going to be on the second page because 1.3 is positive. Now, 1.3 is the same as 1.30. So we go to the 1.3 row, and then we find the value that is under the 0.00 column, and that's 0.9032. Now that 0.9032 is everything to the left of the number we looked up. The table always gives you the area to the left of the number you look up. So we know that all the area under the curve, all of this green area we know is 1. If the green area is 1 and the red area is 0.9032, subtract and you will get 0.0968. That's the probability that Z is greater than 1.3. It asked us for a percent, so we answer with 9.68%. Part E. Not the world's greatest looking normal curve, but we'll pretend. Okay, both of these numbers are positive, so they go to the right of 0. We're being asked for the area between 1.11 and 2.49. Now, let's look up 2.49 in our table. So you go to the 2.4 row until you're under the 0.9 column, and you get 0.9936. That is the area from 2.49 all the way to the left, 0.9936. Now let's look up 1.1. actually 1.11. So we go to the 1.1 row until we're under the 0.01 column, and we get 0.8665. So everything to the left of 2.49 is what's in blue. Everything to the left of 1.11 is what's in green. We're trying to find what I've shaded in black. We're trying to find the probability that Z is between 1.11 and 2.49. Well, to get the black area, you take that big blue area and you subtract the green area. So, as a probability, if it asked for a probability, we would answer with 0.1271, but it wants the percent, so we answer 12.71%. Going on to part F. The area between negative 2.3 and 1.09. Okay, negatives are to the left of 0, positives are to the right of 0. We're trying to find this area between. We're trying to find this red area. So if we look up 1.09 in our table, you go to the 1.0 row until you're under the 0.09 column, and you get 0.8621. Go back to the first page of the table, look up negative 2.3, which is the same as negative 2.30, and we get 0.0107. That's to the left of negative 2.3. We know the green area. We know the blue area. We want to find the red area. What do? We subtract. So it's going to be 0.8621 minus 0.0107. The probability is 0.8514. It asked for a percentage, so we're going to answer with 85.14%. Part G. To the left of, meaning less than 4. So we're trying to find this area right here. Now, if you look up 4 in your table, the positive numbers are on page 2. You see it only goes up to 3.49. Anything above that is so far away from the mean. Remember we said that about 99.7% of the scores in a normal curve lie within 3 standard deviations of the mean? Here, we're 3.4 standard deviations away from the mean, or in our case 4. That's so far away from the mean that we say that there's almost nothing in that tail, which means that there's almost 1 of the area to the left of it, and since it wanted a percent, we answer with approximately 100%. When you run off the table, that means there's almost nothing in the tail. If you wanted the tail, you'd answer approximately 0, but we want to the left of it, which gives us approximately 1. Now, The last one, part H. The probability that z is to the left of, meaning less than negative 3.51. Well, negatives are to the left of 0. And the negative z's are on the first page of our table. If we go back to the first page, though, you see again it only goes to negative 3.49. You see how it goes 0.003, 0.003, 0.002 at the end? It's approaching 0.0000. That's how much area is to the left when you run off the table, approximately 0. And since it asks for a percent, 0 as a number is also 0%. So whenever you're off the table, the answer is going to be 100% if you want the piece that's not in the tail, or 0% if you want the piece that is the tail. So let's see if we can summarize what we have done here. Whenever you're looking up an area to the left of a number, you answer with what's in the table. Whenever you're looking up something to the right of a number, you take what's in the table and subtract it from 1. And whenever you're trying to find what's between two z values, you take the bigger probability and the smaller probability and you subtract them, the big one minus the small one.